Hello and welcome. So, in this video, we're going to be finishing up talking about Markov chains. We're going to be looking at absorbing Markov chains. So, what does that exactly mean? Well, let's start with this transition matrix. This P equals 0.3, 0.6, 0.1, 0, 1, 0, 0.6, 0.2, 0.2. So, remember that in a transition matrix, each of these rows and each of these columns represents a state. The rows represent the state that we're starting in. The columns represent the state that we're transitioning to. And these represent the probabilities of transitioning to that particular state. So for example, if I'm in state 1, the probability of transitioning to state 2 is 0.6. The probability of transitioning to state 3 is 0.1. If I look at row 2, though, notice that the probability of transitioning from state 2 to state 1 is 0, and the probability of transitioning from state 1 to, or from state 2 to state 3 is 0. The probability of transitioning from state 2 to state 2 is 1. And remember, all the probabilities of the row have to add up to 1. So if I look at this entry, since it's equal to 1, it's impossible to leave this state. So once you're in state 2, you're there. You're not going anywhere. So when this happens, we call this an absorbing state. So a state of any particular number, I, of a Markov chain is an absorbing state if the probability of going from that state to the same state is equal to 1. So based on that, now we can use that idea of an absorbing state to talk about what's called an absorbing Markov chain. So a Markov chain is an absorbing chain if and only if the following two conditions are met. One, the chain has at least one absorbing state, and two, it is possible to go from any non-absorbing state to an absorbing state. So, for example, if I give you the transition matrix 1, 0, 0, 0.3, 0.5, 0.2, 0, 0, 1, and they're going to ask you to determine, is this absorbing? Well, again, the idea is this. First of all, do I have at least one absorbing state? The answer to that is yes. We have two absorbing states. State 1 and state 3 are absorbing. So that's the first check. So step 1, that's a check. So for step 2, is it possible to go from any non-absorbing state to any absorbing state? Well, the only non-absorbing state is state 2. So is it possible to go from 2 to 1? Yeah, there's a 0.3 probability. Is it possible to go from 2 to 3? Yeah, there's a 0.2 probability. So is it possible to go from a non-absorbing state 2 to 1 and 3? The answer is yes, so therefore it checks. So therefore it is absorbing. Okay. So another example, this time they're going to give us 1/2, 1/2, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, and then 0, 0, 1/3, 2/3. And they're going to ask you to determine, is this Markov chain absorbing? Okay? So again, first things first, is there at least one absorbing state? The answer is yes, there are two. State 2 and state 3 are absorbing. So that's a check. So then the second step to determine is it possible to go from a non-absorbing state to an absorbing state? So 1 is non-absorbing. So notice Is it possible to go from 1 to 2 or 1 to 3? And the answer is yes. It's possible to go from 1 to 2. The probability of going from 1 to 2 is 1/2. So then we have to check the other non-absorbing state, and that's state 4. So is it possible to go from 4 to 2? No. Is it possible to go from 4 to 3? Yeah, it's a 1/3 probability. So is it possible to go from any non-absorbing state to an absorbing state? Yeah, so that's a check. So therefore, we can say that this chain is absorbing. Okay. So in our next example for this one, again, it's going to be a 4 by 4. So you're going to be given 0.60, 0.40, 0.1, 0, 0, 0.9, 0.1, 0, 0, 0, 0, 1. Okay. So I got to check number 1. Do I have at least one absorbing state? Yeah, we've got 2. 2 and 4 are absorbing. So that's a check. Okay. So if I look at state 1, so that's row 1, is it possible to go from 1 to 2? The answer is no, that's a 0. Is it possible to go from 1 to 4? The answer is no, that's a 0. And even then, we can check the bottom row. Is it possible to go from 3 to 2? Nope. Is it possible to go from 3 to 4? Nope. So therefore, this is not a non-absorbing. So because we didn't meet that second condition, we state that this is non-absorbing. Okay. So now we can use this idea to help us identify long-term trends given transition matrices. And that's where the ideas of a property of an absorbing Markov chain comes in. So there's a few properties. So property number 1 is that regardless of whatever state you start with, in a certain number of steps, the chain will eventually enter an absorbing state and it will stay in that state. 2, the powers of the transition matrix get closer and closer to some particular matrix. We've shown that in previous examples. 3, the long-term trend depends on the initial state. 4, so we're going to let P represent a transition matrix for an absorbing Markov chain. What we do here is that we take the columns and the rows and we rearrange it to where it's in the following format. Where in the upper left-hand corner, we have an identity matrix where M represents the number of absorbing states. Our O represents a matrix of all zeros. And then our R and our Q represents the non-absorbing states. So once we set that matrix up, we would use R and Q to help us find what's called the fundamental matrix. So the fundamental matrix is used to help us identify the expected number of visits to each state before absorption occurs. So to find the fundamental matrix, we use I of n minus q, and we take the inverse of that. And we say that I of n is the same size as q. And the element that's in row I, column j, gives the number of visits to state j that are expected to occur before absorption, given the current state is I. Okay. So then last but not least, if I take the fundamental matrix and I multiply it by whatever R is, that will give us the matrix of the probability that a particular initial non-absorbing state will lead to a particular absorbing state. So again, it's the idea of transitioning from this idea of an absorbing state to, or from a non-absorbing state to an absorbing state. So let's take a look at an example. So for example, if I give you the matrix P equals, we have 0.3, 0.2, 0.5, and then we have 0, 1, 0, and then we have 0, 0, 1. And they want us, it says find the long-term trend. For the transition matrix. Okay, so first things first, what we're going to do is we're going to take this matrix and we're going to rewrite it in this form here. So notice that in the bottom right-hand corner of the matrix, we have an identity matrix that's 2 by 2. So I'm going to rewrite this. I'm going to shift row 1 over, and I'm going to swap. So in the upper left-hand corner, I'm going to put 1, 0, and I'm going to put 0, 1. It's going to look something like this. So then now, because I rewrote this, so because I shifted this row over, the 0.2 is going to come down here, and the 0.5 is going to come down here. And then this first column gets shifted and moved over here, so it'd be 0, 0, and then 0.3. So this is our new matrix. So the upper left represents our I of M. The lower left represents our R. The lower right represents our Q. And the upper right represents our 0. Okay? So now, once we've done that, we can identify R and Q. So we know that R is equal to the matrix 0.25, 0.5. And we know that Q is equal to 0.3. Now that we've set that up, now we can find the fundamental matrix. So now we can say F equals I of N minus Q, and we take the inverse of that. Well, notice that we've only got one entry here. So this would be the identity matrix of 1 minus Q. Well, the identity matrix of 1, that's just 1, minus 0.3, we take the inverse. So 1 minus 0.3, that's 0.7. When we do the inverse of 0.7, we end up with 1 over 0.7, which if we were to simplify that becomes 10/7. So this 10/7 tells us the expected number of steps before ending up in an absorbing state. That's what that tells us. Okay. So now we calculate F times R. So when I calculate F times R, we have 10/7 times 0.2 times 0.5. So when we multiply, we end up with 2/7 and we end up with 5/7. So what does this answer tell us? Well, that tells us that if I start in a non-absorbing state, so our non-absorbing state was state 1, there's a 2/7 probability of ending up in absorbing state 2, and there's a 5/7 probability of ending up in absorbing state 3. Okay, so I'm going to go ahead and stop here with this video. As always, if you have any questions, feel free to send me an email asking me your questions or send me an email requesting a Google Meet. Your assignments will be posted for Markov chains. Until next time, we will talk to you later. Have a great day.